Michelle wanted to know, why can we replace W with mg? So your first instinct, I saw an attempted explanation at this. Your first instinct might be to say, well, W is a force, so W equals some kind of F, and Newton's second law says F equals ma, but if you're following, ma is mg. That doesn't work. It doesn't work because most of the time, A is not equal to G. Unless you're dealing with the case that an object is falling freely. In that case, it's true. But most of the time, that's not the case. So you can't just do this. So to understand where this comes from, let's go back to Newton's second law, which says that the sum of the forces on an object equals its mass times its acceleration. And if we want, we could put vector signs on here. So there's really like a left-hand side to Newton's second law and a right-hand side to Newton's second law. On the right-hand side is the acceleration of the object times its mass. And we're saying that this acceleration depends on all of the forces that are pushing and pulling on that object. Now there are many different types of forces in nature, and each type of force has its own equation associated with it. So on the left-hand side of Newton's second law, we're adding up all these forces that may be pushing or pulling on an object, and each of those forces might have its own associated equation. So we've already learned several types of forces with certain equations. So we know we've learned about, say, normal force, sometimes normal force is an object's weight, sometimes it's weight times cosine of an angle if it's on a slope. We've learned about friction. That has this formula mu times n. We've learned about tension. We've learned about just pushes and pulls, which we usually describe with simply F. And of course we've got gravity, which so far we've been writing as W. And because this is on the left-hand side of the equation, we're just saying that this force has some value, and we might end up combining it with several of these other forces. There may be gravity force and a normal force and a tension force all acting on an object. And when you add all those up, then you get the object's mass times acceleration. And you can solve for acceleration that way. Now, so far we've been saying W equals mg. And up to this point in our physics knowledge, this is essentially a fact. Just like friction equals mu times n is a fact about friction. W equals mg is a fact about gravity. Now, in a few weeks, we're going to learn in a little more detail where this fact comes from. And I'll just give you a preview right now. It comes from another thing that Newton figured out. He figured out a lot of stuff. This is Newton's law of universal gravitation. And it says that the gravity force of gravity between any two objects equals some constant number g times the mass of object 1 times the mass of object 2 times the distance between object 1 and 2 squared. Sorry, divided by the distance between them squared. Now, if you're on the surface of the Earth, this equation simplifies it is this constant number g times the mass of the Earth divided by the radius of the Earth squared times that other mass. And we just give this thing a convenient name, little g. That combination of numbers happens to equal 9.8 meters per second squared. So we say that the gravity force for objects on the Earth is m times g. And it's tradition to name that w. So we'll learn more about this later. But the important thing to keep in mind is that mg is an expression that tells you how big this force is. It's not an expression that comes from Newton's second law using acceleration. So we didn't need to use the right-hand side of Newton's second law to come up with this fact, W equals mg. That is a different law of physics, the law of gravitation.